Today we're going to be talking about factoring GCFs and factoring by grouping. Our objectives are that we'll be able to factor the GCF out of a polynomial, and we'll be able to factor polynomials with 4 terms by grouping. So what is the greatest common factor in a polynomial? It is the largest monomial that divides evenly into all terms. So if we wanted to figure out the GCF, which is the abbreviation for greatest common factor, of 15x cubed y squared plus 20x to the 6th y to the 3rd minus 10x to the 4th y, first we're going to look at the numbers. So what divides exactly into 15, 20, and negative 10? That would be 5. What can we take from all the x's? What's the greatest degree that divides into all of them? So we have a 3, a 6, and a 4. Let's pretend this is money. If I need to borrow money from all 3 of these people, they're all going to give me the same amount. The most anybody could give me is 3 because that would wipe this person out of money. So it'd be x to the 3rd. What's the greatest degree of y that fits into y squared, y cubed, and y? That would just be y. So basically you're looking for the lowest exponent for them. Therefore, the GCF is 5x cubed y. Now, if we want to factor out the GCF, we're going to divide all of these by their greatest common factor that we just figured out. And factoring out the GCF is like distributing but backwards. So we're going to take the GCF and put it out front, and then what our answers from the division are what goes in the parentheses. So 15 divided by 5 is 3. We had 3 x's, we took all 3 of them out, so there won't be any x's left. And we had 2 y's, we took 1 out, so there's 1 left. 20 divided by 5 is 4. We had 6 x's, we took 3 of them out, so x cubed. And we had 3 y's, we took 1 out, so we have y squared. Negative 10 divided by 5 is negative 2. We had 4 x's, we took 3 out, there's 1 left. We had 1 y, we took that y out, so there's no y's left for that term. The way you can check your answer is distribute this back to the 3 terms, and you should end up with our original polynomial. Let's try it again. So if we want to find the GCF of 3a squared minus 12ab plus 9b squared, the greatest number that divides exactly into 3, negative 12, and 9 is 3. They don't share any of the same variables. There's no variable that all 3 terms have. Therefore, the GCF for this polynomial is just 3. So to factor it out, we're going to divide all the terms by 3. 3 goes on the outside. 3 divided by 3 is 1, so we just have a squared. Negative 12 divided by 3 is negative 4ab plus 9 divided by 3 is 3b squared. What about the GCF for 5x to the 4th plus 8x cubed minus 2x squared? The greatest number that divides into 5, 8, and negative 2 is just 1. And the greatest degree that we can take from x to the 4th, x cubed, and x squared would be x squared. So our GCF is 1x squared, or just x squared. Oops. There's a typo there. That should say 5x to the 4th plus 8x cubed minus 2x squared. Alright, so if we want to factor out the GCF, we're going to divide all of them by x squared. So x squared goes outside. 5x to the fourth divided by x squared would be 5x squared plus 8x cubed divided by x squared would just be 8x. And negative 2x squared divided by x squared would just be minus 2, because the x squareds would cancel out. Now, the steps for factoring four terms by grouping. Basically, all we do is we find the GCF of pairs multiple times. So, first, if there's a GCF, we're going to factor that out. There's not always going to be a GCF for the whole problem. Then, we're going to group the first two terms and the second two terms. We're going to do this by putting them in parentheses. Then we're going to factor out the GCF from each pair. The GCF from each becomes one of the parentheses that we have as our factors, and the matching parentheses are the other factor. So our examples. Group the first two. Find the GCF. So the biggest thing that these two have in common is x squared. So I'm going to divide out x squared, divide out x squared. X squared goes outside, and I'm left with x plus 2. 3x and 6 have a 3 in common. So I'm going to divide out 3. So positive 3. 3x divided by 3 is x. 6 divided by 3 is 2. So if you notice, these two parentheses match. That has to happen every single time. Those two become one of our factors, and the GCFs are our other factor. So let's try it again. Group the first two, group the second two. 3x cubed plus 9x squared have an x squared in common. Take out x squared, and I'm left with x plus 9. My second parentheses, they both have a negative, and they're both divisible by 2, so I'm going to divide by negative 2. So minus 2. Negative 2 divided by negative 2 would be positive 1x. Negative 18 divided by negative 2 would be positive 9. So the parentheses that match is one of my factors, and my GCFs are the other factor. Group the first two, group the second two. The first two have 5x squared in common. So I'll take that out, and I'd be left with x plus 5. X and 5 kind of look like they don't have anything in common, but everything always has a 1 in common. So we're going to factor out positive 1. We'd be left with x plus 5. We still have our matching parentheses. And then our other factor is 5x squared plus 1. Now in number 4, something special happens. If you notice, all of these terms are divisible by 2. So I'm going to divide by 2 to start out. So I would get 2 times 2x cubed plus 2x squared plus 3x plus 3. For now, I'm going to ignore that 2 out front. Let me do it this way. I'm going to pretend like it's not there. And I'm going to group these two and these two. These have a 2x squared in common. These two have a 3 in common. So my factors would be x plus 1 and 2x squared plus 3. But what about that 2 from earlier, this 2 up here? In each line, I'm going to bring it down and put parentheses around my whole thing. And then here, because everything's in parentheses, I just put it out front. That's all for today. I'll see you.